do us a favour, guys, and just put your names on there for us. Should we crack on while that's just going around? Cool. Right. Gentlemen, thank you very much for this evening. Those of you that don't know me, I'm Damien Walker. I'm the Managing Director of Ashcroft UK. I'm also on the committee for the IMC as well. And it's my privilege today to talk to you guys about LoraWAN. And more importantly, for me, being a sales guy and running a sales company, one of our LoraWAN products, but we'll talk about the infrastructure first. So what is LoraWAN? It's a new terminology going around industry now, and it basically stands for Long Range Wide Area Network. And it's all to do with something else that's going around, another term going around called IoT, or Internet of Things, or IIoT, Industrial Internet of Things. And all it is the remote connectivity of all your instrumentation and all your devices. It's no different to your Apple phone connecting to your iPad, your Hive system connecting to your phone, so you can control things and view things remotely. And that's all the IoT, and that's what LoraWAN is helping to connect through. So LoraWAN, it's a radio transmission. It's based in the UHF part of the spectrum. 863 to 928 megahertz, depending on where you are globally. In the UK, we generally use 868 megahertz, and the devices that you've got, the little black boxes in front of you, work on that chipset. But there's chipsets for no matter where you are. So LoraWAN, as I say, it's the newest technology to come out to get your telemetry back, to have your control remotely of all your devices. And it's got advantages over existing infrastructure like Bluetooth, Wi-Fi, wireless. And they're really simple. It's got a long range. When you look at a Bluetooth network, you're talking 10, 15 meters, wireless, 100, 200 meters. This particular LoraWAN product here has a range of 25 miles line of sight. It has a very low power consumption. The little cylindrical thing next to the air comms here is the battery for this device. Now that battery can connect 8 different instruments to that air comm and power it locally for a minimum of 3 years. It's a very low cost solution to get power into the system. It has a wide area of coverage. As I mentioned, it's 25 miles point to point line of sight from that antenna. So you've got a 50-mile diameter maximum. So it's a good wide area. Because it's in the megahertz and the UHF band of the radio frequency spectrum, it can penetrate in obstacles such as buildings. When I go on to the demonstrations later of the installations we've got actually in this area, you'll see why it's so important. Cost effectiveness. LoraWAN is free. To use that part of the radio frequency spectrum is free. Ofcom do not license it. So all of your telemetry that you send back over that radio wave is free data. Scalability. Because, and you'll see this later on in about 8 or 10 slides later, how easy it is to add a LoraWAN product into the LoraWAN network. It's no different to a Wi-Fi network. Imagine your Wi-Fi router and then someone coming into your house and then just using that password, getting onto your Wi-Fi. LoraWAN works exactly the same way. As long as you've got the application key, the security key to get in, you can just keep adding and adding and adding. So they're the advantages over everything else out on the market at the minute. And like I said, spectrum efficiency is free to use. So there's thousands of LoraWAN products on the market, and I mean thousands. Once LoraWAN was thought of about 8 years ago, people started jumping on the bandwagon and creating lots and lots of them. And they're all capable of doing a certain amount of things. This particular LoraWAN product you see in front of you is the most adaptable one in the market, and it has been for the last 5 years. And I'll explain a bit more later why. So we'll go over it. So we call it AirCom. But typical Brits, we love an acronym. AIRCOM stands for Advanced Intrinsically Safe Radio Communication. That's all it is. And we designed this product, I'd say about 5-6 years ago, in collaboration with Engie in France. Now, this product is utilised predominantly in the gas networks at the moment, but there's so many other uses for it, as you'll see, and when we talk about it. But we designed it purely for the gas network, so we've got a few key features of this that are only relevant for the gas networks. But when Engie came together with us and said, look, we want a LoraWAN transmitter, we want it to have a minimum of 2 inputs, and we want it to have a battery life of between 5 and 10 years. So this is what we created. So this is the first iteration of AIRCOM, as you'll see. This one, the only difference you'll see with this one is if it was on the side view, it's only got 2 gland points and 6 screws. This now is an injection molded casing with 4 screws and 5 gland points because you can get the cable in a lot better. But it hasn't really evolved since the first iteration because we future-proofed it so much at the back. So, reasons why this is the best on the market at the moment. This is the only LoraWAN product in the world that's ATEX Zone 0 Class 2C, even with the cover off. Designed purely for the gas network. So you can take that into any ATEX Zone 0 environment and install the battery, uninstall the battery, program it in that zone. No one else can do that. It's the only LoraWAN product in the market that's fully open protocol. So by open protocol it means it doesn't matter which manufacturer's equipment you connect to it. Now I work for Ashcroft, but we have this connected to Siemens, Yocker, ABB, anything you want. We kind of call it the slut of the LoraWAN world because it'll get into bed with any manufacturer you want it to. But that's the 2 main key advantages over everything else in the market. If you buy the Yocker equivalent, it will predominantly only talk to Yocker devices unless you program it to default it away from its manual settings. This doesn't need to do that. Straight out of the box, fully open protocol. We can do more than a 10-year battery life. Originally, it was designed for 3 to 5 years, but when I show you the installations actually in that building you see on that image, we've managed to elongate that particular battery to 14 years before you have to swap it. The AIRCOM actually powers your analog instruments. So if you've got a pressure transmitter or anything like that, this physically powers your instrument. You don't need to have local power. Cuts your costs down again. So initially, we had 3 variants of this. The 1 input, the 8 input, and the 11 input. You cannot physically tell the difference between the 3. They all look the same. That is an 8 input version, that is an 11 input version. They're both capable of exactly the same task. All we've done is we've just jigged around with the chip to tell that that's 8 input, but actually it can be opened up to full 11. You don't see the difference. But as I mentioned, it talk to anything. So you've got the 8 input, which is the one we sell every day. You've got 4 digital, 2 serial, 2 analog. Now, any manufacturer, any instrument on there, we can talk to it. If you're using a thermocouple, it actually has the transmitter head built into the AIRCOM as well, so you can remove your puck from your system. We designed this with heart, purely because when we were looking at this originally, when we were integrating it with some of the Siemens equipment, they specifically asked for us to put it with heart, so we added that into it as a final change before it went into production. But as you'll see when you look at the videos we put on later and you look through the menu tree, it's so easy to use and it's all available. So here's some examples of what we've used it for so far. Gas quality, pressure and temperature, cathodic protection, flow volume, electric metering, etc., etc., etc. Now I said that AIRCOM will talk to anything, and it will. But there's a word on that top sentence there, it will monitor almost any instrument. The only thing you will never put down any LoraWAN device is CCTV, because the packets are large and you'll want a constant image. No LoraWAN device in the world does that. So across Europe, we have a thing called a gentleman's agreement with LoraWAN. And that means that every single input on that device can only transmit no more frequently than once every 2 minutes. So the AirCom will power up the instrument, let it stabilize for a predetermined length of time, take a reading, transmit the reading, and then power down the instrument. So no LoraWAN product will ever be a SIL product because products aren't left live ticking over. There are ways around that, and I'll talk about that later when I show you the live applications. But generally, they're the only things you do not put down any LoraWAN product. The AirCom is an incredibly low-cost device compared to what it can do. Okay? It gives you local power. It has the open protocol that I mentioned. It has military-grade encryption. Okay? That AirCom has what we call AES NIST accreditation with security. The same level of security I used when I got out of the Army in 2000. A triple 128-bit encryption key is on there. The US and the British government are still using that level of encryption now. It's got integrated I/O. It's got 4 digital input outputs on there, and we can get the AirCom, we can program it to do action on event. So it can look at a particular reading from any particular input, and you can say to it, okay, if I get to this level, I want you to do X, Y, and Z, and it'll do that through the digital I/O. It takes the reading in, then transmits it out. It's IP68, and as I mentioned before, it's the only ATEX Zone 0 Class 2 LoraWAN product in the world right now. It's got an incredibly low cost of installation. As you'll see from that image there, and if you have a look at the back of the AirComs, you either put 2 U-bolts on it or 2 screw mounts on it. That's it. Any monkey with a spanner or screwdriver can install this instrument. Now it has no or low data costs. Now I mentioned LoraWAN is free to use, and it is. You will never ever pay for your transmissions, but we have a variant of this that has an option for a 5G SIM card in it. And we designed that for areas like in the deepest, darkest highlands or the west of Wales where there's nothing but shit and sheep and you cannot get your receiver station within 25 miles line of sight. So then we piggyback off the mobile phone network. But that is the only time that you'll ever pay for data with our particular product. It's programmable from your phone if you want it to be. And you'll see from the images later, it can be done from that. And it's done by a free app in the App Store or the Google Play Store, and that's what it looks like. The app is incredibly intuitive to use. Everything follows the same subroutines. And this is what it looks like. So that's what it looked like on your screen. Now, this is a few examples of different pages on there when you're editing, etc., etc. If you make any changes or want to make any changes to the software, you click on an edit button. If once you've made your changes, or after you click on that and you click on a particular tab like the start time, either a wheel will fall down and you just choose where you want to be on the wheel, or a drop-down menu will appear and you just click on the one you want. After you've made your changes, you press the 3 lines on the top left-hand button, go back to the main screen, then click the save button, and the save button looks like a little floppy disk. That will then get saved into the device and it's done. Everything you do follows the same subroutine, so you don't have to be a wizard with this. And when you see the videos later on in the presentation, you'll see how easy it is to use. As I mentioned, you've got 25 miles line of sight, but it's down to topographical constraints. But the device on the right there, that thing is the gateway. So LoraWAN always talk about LoraWAN transmitter and a gateway. The gateway is always the receiver. Okay, there's lots of different variants of gateways, and with the advantage of this particular AirCom being open protocol, you don't even have to buy our gateway. It's like buying an unlocked mobile phone and then using it on the Orange network. You don't have to pay for a subscription into Orange. Okay, we will talk to any other LoraWAN network. So as long as you've got the application key or that Wi-Fi password, we can get on that network and we can utilize it. So it's another cost saving there. So I mentioned here, yes, encryption. It is the gold standard for all communication encryption globally. Now you see this last quote here. I have no idea what a petaflop is, but back in 2017, when it is now the 4th most powerful supercomputer in the world. The Chinese said they were using it for weather monitoring, if you can believe that. But because of the level of security, those triple 128-bit encryptions and the additional 64 key that you'll see later, it would take 885 quadrillion years just to brute force it. So the sneaky little Chinese and the Russians aren't going to get onto your network, take your data, and mess around with the utility networks that are using it now. We've had to use that level of security because we focused this with the utility markets in mind. You know, big pharma, big petrochem, the gas networks, the water networks, they need this level of security. Not one of them, in my experience since we've introduced this product, have had a problem with this software. As soon as we tell them what level of encryption they've got, they just shut up and they're quite happy to put it on their network. So we created and we future-proof the security on this as well. So there's 3 options on how you can use your app key, your password. Now imagine if you go to someone's house, they give you the card and say, you know, the password is either the default one that came with the router, or they might have got onto the admin settings and changed it to, you know, John Noon 1 at Hotmail. Sorry if I give it away. Or the final version, which no one has used yet, is we can get this to generate a brand new encryption key with every single transmission. So if you've got that particular product with 11 instruments connected to it, every input which will transmit will create its own key. So imagine the Enigma code on steroids. No one has ever used that yet. Everyone normally uses the one that's defaulted with the Aircom, and you can create your own, but that's all they ever use. But you've got that level of security there in the background if you need it. So this is what the gateways look like now. So they look like the Aircom, just a white box and a black antenna, so we can identify them easier. And as I mentioned, you've got 25 miles point to point. So we have topographical constraints. Imagine if we're the other side of the Peak District, we'd have a lot less range because there's bloody big hills in the way, and you might have to put repeater stations in there, but technically we have 25 miles. So that gateway there is a 50-mile diameter. Imagine that being your mobile phone mast, okay? And you want to get your subscribers within that cell. LoraWAN is exactly the same as that. We have urban area loss. As I mentioned, the Aircom or LoraWAN can penetrate buildings to a certain degree because of the frequency, the wavelength of it, but it will degrade the signal. But one gateway can effectively have, in that 50-mile radius, 11,000 Aircoms connected to it. So imagine the gateway being your mobile phone mast. The 11,000 users are you, me, and all your family and friends with their mobile phones. It works exactly the same way. But each one of these Aircoms is potentially 11 instruments connected to it. Now we can electronically adjust the timing on the gateway to have 255 instruments per gateway. So imagine if you're on a large petrochemical site and you wanted to connect all of your instrumentation to a number of Aircoms or transmitters, you would technically only need one gateway in the middle of your site to get all your telemetry back. No more cable runs, no more cable trays, no more local power because we locally power the instruments. Massive cost saving. But I mentioned this product was designed for the gas networks. So the gas networks in the UK, every single one of them are using Aircom. Now for the past 3 years, not that you guys will have noticed, but But Middlesbrough, Darlington, Stockton, Durham, Hartlepool, who else around here? And parts of Yarm and Leeds are all getting their telemetry back via Aircom. Northern Gas Networks is the most advanced on the rollout, okay? But if you look at Northern Gas, the big orange section here, that's a 25,000 square kilometre area. But because those gateways have a 50-mile diameter, we only need 67 gateways, 67 receivers to cover that area. But that gives us an option for nearly 6 million instruments of telemetry to get back for free. Northern Gas at the moment spend up to £5 million a year getting their data back from all of their regulator stations. £5 million a year on the lease of ISDN, PTSN, 3G and 4G cards. LoraWAN's free. For the price of 67 gateways and then a number of Aircoms to get your data back over the network is free. 5 million a year. Cadent Gas, they're 5 times larger, roughly, when it comes to their regulator station network than Northern Gas. So that's a potentially £25 million a year saving after you get rid of your initial install cost. It's ridiculous. We're hoping that with this rollout, that the gas networks, utility networks, then turn around and start giving the end users a bit of a cost saving on their bills. But they're not going to do it. But this isn't the only way that we're saving money on them. So this is an outline, roughly, of a gas network from source down to the end user. But we're focusing more on the end users here and these regulator stations. Now, each regulator station will run and govern a number of houses, properties, etc., maybe a couple of streets. You'll have all seen them, little buildings, and you'll see it from the images later. You'll identify them. Each one of them has to put a 20 millibar gas supply into every property at any one time. No less, 20 millibar. And the way the gas networks are doing it at the moment, using their regulator stations, they do a thing called clocking. Twice a day, for 3 hours each time, they open the gas main up to ensure that every house, every property, at the end of that gas line is guaranteed a 20 millibar signal. 6 hours a day at full power. Well, they have to go above full power to get it out. Every gas line in this, every gas utility company in this country loses at least 25% of its product to the atmosphere because of leaks. So for 6 hours a day, they're venting 25% of it into the atmosphere that we're paying for because it's going out. Overall expenditure for them. So we're hoping we can save them money from doing that. And what we do is in the regulator stations, which look like this, we've offered them a main and a standby aircon. And on this particular one, this was the first ever install, and this is happening on the outskirts of Leeds. We're using the Siemens pressure transmitter. We're reading that 20 millibar signal. Then every 2 minutes, because the aircon will power up the instrument, take a reading, send it off, it will look at that, and then it will use a digital I/O to open or shut a solenoid valve. So if the gas supply starts dropping below the 20 millibar, within 2 minutes it'll open a valve and get it back to 20 millibar. Whereas historically they go full pelt, 3 hours, then down, stabilize. Full pelt for 3 hours. So every 2 minutes we're opening or shutting a valve. Another massive cost saving to the gas networks. Will we see it? Probably not, but we're doing that. What we can also offer, so we're offering additional power. Now, with those Siemens transmitters, looking with that particular battery there that you see on the desk, they will last for a transmission every 2 minutes for about 5 years. So we offer additional battery packs for solar powers. We can now get that to plus 10 years on there. So you see that is one of the install methods, 4 screws. The next one is 2 U-bolts. This was the first ever trial installation for Northern Gas. You see it's powering up the transmitter and taking the reading off the bund. All you need to do is have your supply into the measurement point and then your power cable going into the aircon. That's it. This is one for Andre in France. This is cathodic protection. This is a far more secure option for the install because it's on a metal pole, not a wooden one. That's how secure we need to be. But that's it. Now this is quite interesting. This is actually in Wales. Now, this was the first time that we changed the gateway from the small unit you saw on the first slide to the normal aircon box, and it's black on this particular instance, but it's got a large antenna. And then we put an additional power pack in there with a solar panel. Now it's a big solar panel because we're in Wales and they don't get a lot of sunshine, so we have to get as much power back in and then batteries to recharge them as possible. But if you look at this area here, that corner of that is actually this building, which looks like that. Inside this ISO container, this prefab building, we've got one aircon connected to the gateway outside with the power source. We've got some Ashcroft pressure transducers, so we've taken off the Siemens ones now and put the Ashcroft ones in there because they've got a faster response time. They use less power. So with the individual battery you've got there, with that layout there, with them two supplies, we can make that battery last 14 years as opposed to 5. But what's interesting about this building is there is no external power to this entire building. That aircon and that battery on your desk and the battery pack outside are powering up the aircon, the transmitters, the heater, the door contact, the slam shut valves, and the pressure release valves as well, all from that little battery. So imagine trying to get power to a remote site as a utility company, the infrastructure that you'd have to put in, the cost. We can do it for the sake of a small battery box, a couple of car batteries and a solar panel. Done. This site here, this is what we call a profiling rig. So you've got your main and your standby, your pressure transmitters, you've got your valves, your pumps. Again, this building here has no power. But this building doesn't even have the external battery pack that it does from the other one. This is 3.5 miles away from the one in the other building. And again, this is powering the valves, the transmitters, the heater, the contacts. And then sending everything back to the gateway you saw previously and getting it back onto their DCS or SCADA, however they want to deal with it. Massive cost saving again. The amount of infrastructure you can remove by using these is phenomenal. We design these profiler panels depending on how the gas companies want to work. You'll see we've got different versions of it. Some more over there. So these are the transmit side, the transmit and control. Then going back into your DCS, your server, your SCADA, whatever you want to do, we have a gateway that can do that. So we've made a cost saving on the telemetry because the data is free. We've made a cost saving on constantly measuring the supply, turning it on and off, on and off. We'll also make another cost saving. If you've got a Modbus gateway, okay, one gateway can service 11,000 aircoms, 88,000 instruments. You only need one port on one card on a Modbus gateway. Imagine hardwiring 88,000 instruments into a Modbus gateway. The cost of that alone is phenomenal. What we can also do, if we know what the Modbus registers are, we can always pre-program it as well. So it's literally straight out of the box, plug and play. That's all it needs to do. Another massive cost saving for everyone. And this is why the gas networks now are rolling out with our particular product. Another service we can offer is we can create the server package, your front end. We can design that however you want. This is a very basic one that I normally use for technical demos, and it's really simple to use. So you've got a date time stamp of your last physical reading of 2 particular inputs. On here, on input number 1, you've got pressure. On input number 2, you've got temperature in this example. You've got the name of the aircon or your LoraWAN device. Now, normally you can name that whatever you want. You can call that, Mike Val's regulator station number 1. One thing you can't change is the serial number on this software. It correlates to the serial number on the side of the box. And when you look at the video in the next few slides, you'll see why. Then you've got your last physical reading of input number 1, last physical reading of input number 2. You've even got the voltage of the battery in the aircom. So you could be 25 miles away and know how much battery power you've got left in there. We can even program the aircom to determine when you have to go out and do a maintenance event. So if you've got 8 instruments wired to it, and we know that they last for 5 years before that battery runs down, we can say to the aircom, when you get to 2.6 volts, you set up a maintenance event on the server to tell them that the guy has to go out in a van and swap the battery. To swap the battery, it's 4 screws on the lid, battery out, battery in, 4 screws back on the lid, walk away. It's already pre-programmed, it'll just carry on working. That's how simple it is. We can do that. You've also got the temperature of the microprocessor in the aircom. Now, we know from, if any of you have got electric cars like I've just got rid of, when it gets to extreme cold, that battery power drops off. Conversely, if that temperature goes up to 600 degrees, you know you've got a fire in the building, so you can get someone out there with a big bucket. But it's there to determine, to help you just see what's happening in that environment. And then on here, you've got a drop-down menu where you can actually physically see how much data you want to see. And that is fully customizable. So I've got 1 data point for every hour for the last 24 hours. So you see each line has got 24 data points on it. And that's it. But all that data normally will just go into your DCS or your server and you deal with it yourself, but we can offer that option as well. What I'm going to do now is put on 3 videos. They're about 2.5 minutes each, and after each video I'll just talk you through what you see on there. Video number 2 and video number 3 have a lot of repetition in them, you'll see. If you haven't already, download the app. Insert the battery, wait for the LED to stop flashing, tap with the magnet 3 times to get the LED on, blah, 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 blah. Once you take that repetition out of videos number 2 and 3, this device is programmable out of the box within 5 minutes. Literally 5 minutes. So I'll put the first video on, and then we'll talk you through it.
This video tutorial will explain how to get started with your Aircom device. If you haven't already, download the Aircom app from the Google Play or Apple App Store. Please see our website for the link. First, remove the front cover of your Aircom unit and power on by inserting the battery. Wait for the green LED to stop flashing. When ready, gently tap the indicated square with a magnet 3 times to enable Bluetooth. Open the app and select the Aircom device you wish to connect to. The name of your Aircom device will be the serial number located on the manufacturer's label. Once on the main page, you will be warned that the Aircom device clock is out. To correct this, navigate to the Aircom device status page and update the device time. You will be notified by a green bar at the bottom of the page when this action is complete. Next, you need to configure the LoraWAN settings. The first step is to provide your IT department or network provider with the Aircom device EUI. This is a 64-bit unique identification number. To find your device EUI, navigate to the LoraWAN settings page. Next, a 128-bit encryption key, referred to as the app key, needs to be entered into both the Aircom unit and your network server. Tap the Edit button. Tap the LoRa app key section and then enter your encryption key. Once you're happy with the settings, tap the tick button. Next, write the configuration to the Aircom device. Return to the main screen and tap the Download Configuration button. You will then be notified by a green indication bar at the bottom of the screen when this action is complete. Finally, you need to join your LoraWAN network. To do this, navigate to the Aircom device status page and tap the Join LoraWAN Network button. You should receive a green bar at the bottom of the page when this action is completed successfully. You are now ready to configure hardware and transmissions. Please see our other tutorials.
That is the hardest part about setting up our LoraWAN device onto the network, and it's akin to logging into someone else's Wi-Fi network. If you've got a series of uppercase, lowercase, numbers and letters and all that, and special characters, it's quite easy to get it wrong. You've just got to type in that 128-bit key. Now the 64-bit key is basically the name. So you basically put a 64-bit key into each device and say, this is my name, I'm Bob. And then the 128-bit key is its language. I'm Bob and I want to talk French. And then the network looks at that and says, hello Bob, I speak French, let's talk. We'll handshake, we go. And that's the hardest part about doing this. You see on the video there when it showed you the application, the app working, all the warnings appear at the bottom in yellow or orange. As soon as you make a change and you go back to the main screen and configure it, it will go green. They always follow the same routines, as you'll see from the next video. So the next one now, after you've got the Aircom and the gateway talking to each other, is let's connect an instrument to it. And it's this easy.
This video tutorial will explain how to configure your Aircom device with analog instruments. First, remove the front cover of your Aircom unit and wire in your analog instrument. In this example, we are using a HART-enabled temperature transmitter. For full wiring and instrument options, please consult the user manual. Now, power on the Aircom unit by inserting the battery. Wait for the green LED to stop flashing. When ready, gently tap the indicated square with a magnet 3 times to enable Bluetooth. If you haven't already, download the Aircom app from the Google Play or Apple App Store. Please see our website for the link. Open the app and select the Aircom device you wish to connect to. The name of your Aircom device will be the serial number located on the manufacturer's label. Once on the main page, tap the Configure Hardware button and select Analog Channel 1 or 2. Tap the Edit button and select the desired input source from the list. Here, you can see the supported devices such as active or passive 4 to 20 mA instruments, RTD, thermocouple, and others. As previously stated in this example, we are using a HART temperature transmitter. Next, set the on time. This is the time that the Aircom unit will power on the transmitter before taking a reading. To preserve battery life, it's best to keep this time as short as possible. For our example instrument and most transmitters, 5 seconds is sufficient time to power on and take a stable reading. Once you are happy with the settings, tap the Tick button. You will then be prompted to write the configuration to the Aircom device. Return to the main screen and tap the Download Configuration button. You'll be notified by a green indication bar at the bottom of the screen when this action is complete. You can test your setup is working by navigating to the Readings page. Then tap the Refresh Readings button. The Aircom unit will power the transmitter for the set on time and take a reading. Now the hardware is connected and working correctly, you need to set how often you want the measurements to be transmitted. To do this, watch our transmission tutorial on our website.
So you see in that video there, we're using a status device rather than an Ashcroft one to prove that it's open protocol. Now using that manual there, that little booklet, and the 3 videos you're going to see, we've never ever sold a day's training on this product because every E&I guy worth his salt can read that manual and work out where he terminates his product onto the terminal block inside the housing. The toolkit you get with the Aircom consists of 3 things: an Allen key to open the lid, a magnet to tap on the magnet square to enable the Bluetooth programming option, and a bent screwdriver to help you depress the terminal block so you can put your ferrules in. That's it. That's all you get with it. You saw on there that once you do that and tell it what it is, go back and download it. That's all you've got to do to program it as an instrument. But now, we've got the network talking from video number 1. We've now told it we've got a device connected to it. Now we have to tell it how often do we want that information. All right? This next video, a few more routines in it, but it shows you a number of different options. I'll go into it in a bit more detail at the end.
This video tutorial will explain how to configure the transmission of data from your Aircom device. First, remove the front cover of your Aircom unit and configure your hardware. In this example, we have a single temperature transmitter connected. Now power on the Aircom unit by inserting the battery. Wait for the green LED to stop flashing. When ready, gently tap the indicated square with a magnet 3 times to enable Bluetooth. If you haven't already, download the Aircom app from the Google Play or Apple App Store. Please see our website for the link. Open the app and select the Aircom device you wish to connect to. The name of your Aircom device will be the serial number located on the manufacturer's label. Navigate to the Transmissions page. You can do so by tapping the Configure Transmissions button on the home screen. You have the option to set up to 5 different transmission schedules. This allows you to send different data at different frequencies. In this example, we only need 1 transmission for the temperature. To set this up, tap T1, then tap the Edit button. We can now set the transmission frequency and what data we want to include in the packet. Set the frequency that the packets will be sent. Next, if desired, set a specific start time. If not, the Aircom will start from the day it was configured. If you wish to set an end date for transmissions, check the Has End box and set the date. If not, the Aircom will run indefinitely. Finally, check the data you want on this transmission. For this example, we will only send analog 1 and diagnostic data. Once you're happy with the settings, tap the tick button. You will then be prompted to write the configuration to the Aircom device. Return to the main screen and tap the Download Configuration button. You will be notified by a green indication bar at the bottom of the screen when this action is complete. Finally, you can test your configuration is working properly by tapping the Manually Send Transmission button on the Transmissions page, checking that your packet is sent and that your system received the data. Once you're happy with your configuration, you can disconnect from your Aircom device and reattach the lid. The Aircom will now run the configured transmission schedule.
That's it. So you tell it how often you want information from each of your inputs. Now you say analog instrument number 1, I want it every 2 minutes, but I only want the diagnostic data every 2 minutes. I want the scaled value every 10 minutes. And you can set that up in transmission number 2. You have a start time and an end time function on there. If you don't do that, the minute you put the battery into the Aircom, it will start working and it will just transmit on the frequency that you've told it to transmit on. If you have a start time, what you can do is you can program 1,000 Aircoms in your offices before you go out, get your guys, all the instruments wired up, get them programmed, take them to site. They can put the batteries in and walk away, and you can say to them, right, on the 1st of August at 8 a.m, start transmitting, and it will transmit at that frequency that you've told it to transmit at. And it will do that until the battery runs out. You also have an option for an end date. Now we're doing this quite a lot when we have trials. We have a lot of people that have clamp-on flow meter trials and they want to get their data back. So we're literally just jerry-rigging a gateway out of the back of one of their server rooms. We're going out on site and we're connecting the Aircom to the flow meter and we're setting up the schedule, and we'll say to them, right, okay, you're paying for this trial for a month. On the 1st of August, it will start at 8 a.m. On the 1st of September at 8 a.m, it will stop. And that's what it does. So it'll run for that month and it'll just power down and sit there dormant until you tell it to start working again. But it gives you an opportunity to leave it out there, not run the battery down and not get any more data coming back onto your server. So you've got that option as well. But that's all you need to do with it. Now, you saw on the second video, you can locally test it. When you hardwire your instrument, you can go on your app on your phone or your PDA and say, right, test it, and it will come through, refresh on the screen. When you do on the third video, you tested it over the network. So it went from the instrument to the aircom, to the aircom to the gateway onto your server or DCS, and then you can check it. So you can do all of these checks and balances before you actually install it. Then you give it to you guys, you go out and put it on the whatever installation they want to do. That's all you need to do with this. So those 7 minutes worth of videos, or 5 minutes once you take out install the battery, download the app. Between that and that book, we never ever sell a training day. We have the option to come out and do the install for you guys, and we generally do the first one for free. Then after that, all the E&I guys just take over themselves because they're that easy to do. But we have lots of different ways we can support you on that. What we've done in the meantime, while we built that, because we designed that over 5 years ago, about 7, 8 years ago we designed that. It's been in the market now for well over nearly 5 years now. But in the background, we've been doing a bit of R&D. So we've created, and this product is coming out now, as a mini aircon. It no longer looks like this, because we found out that although it looks nice and neat and cylindrical, it's a pain in the arse to mount to anything. So it's now a rectangular design. It's a smaller version of the aircom itself. But we initially thought, oh, that looks nice. It looks like the old Amazon Alexa volume version 2s. Nightmare to mount onto a pole. It has limited options with it, smaller number of inputs, and it has a reduced range, but it's a far less costly device. Still got ATEX rating, still the same Zone 0 Class 2C. Still works exactly the same, programmed by the app, does everything the same as the old one, but it's just a more cost-effective version. Then we created 2 more versions, the Aircom Q. We've made this modular. Now, as you know, from what I said, we've got a 1 input, 8 input, 11 input version with 4 digital, 2 serial, 2 analog. With the Aircom Q, we've done it more PLC based. So you can say, right, okay, I want the head unit and I want 27 analog, 3 digital, 18 serial. And you just buy the modules, slot them on, got a HMI at the front, and then you can build your own front end. You can do everything with it and do all your telemetry, everything through that. So it's more modular. This is an application, we've done this specifically for the marine industry. I was on site in Aberdeen about 2 years ago with a company called North Star, and we're talking about getting all their vibration sensor details from the ship and the bilge level telemetry back. And we said, well, we can do it from the aircom. You just got to mount them on the, on the outside of the hull of the ship, and we get the data back, or blah, 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 blah. And the guy said, right, I'm going to need about 15 of them per boat, per vessel. And we said, that's fine. And I said to the guy, right, well, how much is it? How much is it going to cost you? How much are you willing to pay? And the guy said to me, well, I have a crew rate of £6,000 per man per week. And he said, I'll lease them off you. Each one, bear in mind, he needed tens of on each vessel, and he had 43 vessels. I'll lease them off you for about £5,000 a month per unit. And I said to him, the sale price of that is only 1,500 quid. Let's just buy a one-off price, 1,500 quid per unit. And he was just like, ka-ching, ka-ching, ka-ching. But they said, right, but this isn't the exact right product for you. So I went back to our R&D team and we talked about this more modular version. Now this will have more cabling involved, because as you saw from the images with that version, the only length of cable you've got is from the gland on the aircom to the instrument, whereas on the vessel you're going to have cable trays going from every instrument into that unit, but it will still work the same way. So it was designed for that market. Then we've also got our physical gas metering version. Now, all these aircoms, every single one of them, have got the same microprocessor in it as your iPhone. So we can program it to do anything we want. It's an incredibly intelligent device. out of the box or a dumb device. They'll take data in, they'll transmit it off and do action on event. We can get it to do so much more. A typical physical gas metering rig is about 50k in a big 19-inch rack. We can do it for one aircom. We charge them a little bit more than 1,500 quid because we know they're paying 50 odd grand for that. So we charge them a bit more for that, but we can do exactly what the physical metering rigs are doing for the price of one box. Now imagine if you're a utilities company, whether it's gas or water, and you're going out to site and you're going to build another monitoring station and you want everything to go indoors. You're building a big room to put all of this instrumentation in. Ours is IP68 and we can fit it in a foam box size unit. So if you're laying concrete to build a cabin, it only has to be tiny. Or just put it in a housing, stick the antenna out of it, it's done. So massive cost saving there. So they're the different variants that we've got now. The Q and the Fiscal are already out, but the Mini will be, I think that's coming, it'll be out in the next few weeks, if not already. But that's it. And that's what we got for Aircom and LoraWAN. Has anyone got any questions? Good thing about these as well, they're all manufactured in the UK. I'm very proud of that. Manufactured in Stoke. So they're a UK product, UK manufacturing, everything there.
How reliable is the handshakes between them? I've got at home a wireless network.
Yep.
And I've got computers that are wired in with cables. I never ever have to reconnect the cables, but I can assure you at least once a day my tablet fails to connect to the network and it says, forgotten or, disabled, and you have to go back in and reconnect. How often do you have to reconnect these things?
Never.
Why?
Because they're stable. It's just a radio communication. As long as there isn't a building put up in the middle of it or a mountain dropped in the middle of your line of sight, it will just work indefinitely. Now, if you tell us where you're going to put your transmitter and your receiver, we've got software where we can determine the best place to site it, what elevation it needs to be at, etc., or whether you need a second gateway so you can packet switch around, because you basically create your own mobile phone network. But once they handshake and they stay there. You can take the battery out, leave it for 5 years, put the battery back in, it'll start working again.
And why is that so reliable, and why is my home Wi-Fi so unreliable?
You pay your money, you take your chance. No, we designed this for the utility network, so it has to be stable. It has to be, and it is. It's the easiest way I can explain it. It was designed purely for the utilities market, so we had to have that level of stability. Now, there's a lot of parity, and handshaking happens constantly with the network.
Is that the difference? It tries to connect and...
Yes. If it doesn't get, if I'm connected to...
It gives up. As soon as it can't connect, it just says, tough shit, I can't connect.
If I can't connect to you, and there's another gateway, it will packet switch round and get to the end source, and it makes sure that the handshaking is done. If I try connecting to you, and you're the only gateway in the network, and I can't get you, it will stop. It will hold the information, it will flag up a notification saying no network connectivity. We'll find out why. Either someone's powered down the gateway, turned off your DCS, or, like you say, dropped a mountain in the middle of it. Once it gets connectivity again, data goes through. It will store the data, and it will hold that data until the RAM is full. Now, each transmission is about 19 Modbus registered size. Okay, 60, 70 bits, something like that. It only has enough, I think it's something in the region of about 100 lots of data dump. So if you've got no comms for 3 weeks and it's transmitting every 2 minutes, you'll lose your back register. Okay, but what you can do with this thing as well is we can pre-program this to sit there dormantly and be on constantly. If you give it a local power supply, so it's not determined off the battery, it will constantly power up your instrument and read it. And it will read it and read it and read it. And as soon as it sees an area where it's a failure point or an alarm point or an action on event point, it will transmit straight away. And it'll just kick in and work. So as I mentioned at the beginning, they're never ever going to be a SIL product, because normally it would power up the instrument, take the reading, power it down. We can get round that. We'll never go for SIL accreditation, and no LoraWAN product will. But we can get around that by monitoring constantly, and only transmit when we get an error or when we get to a point where we need to act. But it will act, then it'll send the failure point. It won't send the failure point, wait for the DCS to come back. It will say, right, I've met a threshold, do X, Y, and Z, transmit at the same time.
So if you lose a transmission, something stops transmitting, I take it it's the gateway that says, I expected something from this, I haven't got it.
Yes, well, it's a bit of both. That will try and transmit to the same gateway, because my name's Bob and I'm speaking French to you. I don't get you, right, can I go elsewhere? No. It will go into an alarm, all right, and it'll just sit there and go dormant, all right? Well, it'll keep trying to transmit, but it won't do anything on that unless it's got the action on event programmed into it, all right? So it can still act, but you won't know it at the back end. Because Bob was talking French to Josephine at the gateway side, if Josephine hasn't heard from Bob, like it is with all of us are married, if your wife doesn't hear from you in 24 hours, she knows, you're going to get some kind of alarm signal. Normally, as soon as you walk in the front door, it will put an alarm on the DCS and say, I've lost comms, because I'm expecting a transmission of the scaled or analog value or whatever. At this time, I haven't got it. What do we do? So you then go get a man in a van, or you get a guy in the server room and have a look, see what's going wrong. So you can do that as well. But that's pre-programmable from the gateway into your server or DCS by you guys, but it is capable of doing that.
Any further questions for Damien? Damien, when you've got a remote station, such as some remote place in Wales,
Yep.
is the equipment capable of powering up things that actually do need a bit of power, like 24 volts, etc.?
Yeah. Yeah. It can power up to.
That's detrimental to the system.
It's only detrimental to the battery supply. So as you saw from the image where I showed you the installation in Wales, that has no local power whatsoever, and it's powered by the battery pack outside, which is recharged with the solar panel, and the small internal battery in the aircon. So it will do that, and it will do that indefinitely. Now, if you tell us what you're going to connect to it and how long it's going to run for, we'll provide the battery backup for it, and we can do that. Yeah, but
Yeah, I was thinking things like that meters where it might need
if it's a 4-wire device, they're very power hungry. The battery on that particular battery on a 4-wire device will last probably about 6 months without the additional source, and that's what it's for.
What about things like anti-condensation heaters? I presume the instruments take bugger all power, but you want 200 watts or something for a panel heater. You can't do that off that battery, can you?
Not off that battery, but off the additional battery pack outside. And those ones in Wales, they've got heater systems in there that stop the pipes from condensing up. Yeah, so it's doing everything. It all depends on what you want to power. It depends on how big of the battery source that we supply.
When you put it for 10 years or 15 years, has that actually been proven in practice?
Yeah.
Or is that theoretical?
That's been proven in practice for over 5 years with everything on the power consumption. We actually have a bit of software where we can determine, if you tell us what you're connecting to it, how often you want to get your transmission out of it, we can determine how long that battery will last, as long as you don't go into adverse cold temperatures.
I've always been a bit sceptical of that, because you buy security cameras and stuff for your house that claim a battery life for 3 years, like buggery that actually lasts 3 years.
No, that's a guaranteed to last for more than 5 years in normal conditions, even with those Siemens transmitters on it. You put the Ashcroft ones on that work on a voltage ratio metric output.
Remote installation is fantastic.
Yeah.
idea for the gas network, it's fantastic. I'm less sure about a chemical plant. I think
But you think about a chemical plant. If you want to do a quick rig up somewhere, think of all the cable trays and everything you've got to run. The only cable you've got to run is from that to the instrument. Now, if you're using the heart device, once you get that heart signal into there, it's secure. It's military-grade encryption. If you've got a heart device on a network, anyone can hack into that at any point and jiggery poke and take your telemetry and do whatever they want with it. Once it hits that device, it's secure. But it was designed purely for the gas networks, but we're starting to roll it out into the water networks as well. If you think about, we're talking about the regulator stations for the gas. If you think about the orthophosphoric dosing applications.
Stuff for your smart meter, why are they using SIM cards
Funny, you know when I showed you the 3 versions, the 1, the 8 and the 11, the 1 input version was designed to get rid of your smart meter. So, but the gas companies have said, you know what, we're not going to use it because we've already rolled out the smart meter and we've got contracts. But that's what we designed it for, to get that data and telemetry back. It's more secure. I mean, I don't know about you guys, but when I got my first smart meter, for about the first 6 months, I had it changed 3 times because it wasn't getting the telemetry into the system. So I used to get a phone call every month, can you go read your meters? No, I've just paid for the smart meter. You get a guy out to come and read my meter. If you look at places like, the UK is incredibly slow with LoraWAN. We haven't rolled it out everywhere yet. But Switzerland, 98% of Switzerland is covered by LoraWAN. Okay, and for €7 a month or Swiss francs a month, you can buy your data package. Okay, so my equivalent in Switzerland has an aircom connected to his oil tank outside for his house, and that gets the data back into the Swiss network for him. But we don't, in the UK, we're very slow in rolling out the LoraWAN network. But if you look at, let me go back to this particular slide here. Imagine you say you wanted to create your own LoraWAN network in this area, and you put 67 gateways in there. You became a mobile phone user, a provider. And then I said to you, I've got a LoraWAN device. I want to use your data network, your receiver network, because I don't want to buy one. You then become the provider of a data service. So you can then charge data back to other users. So if you're in a huge, let's say on Wilton, okay, and you've got, let's say you put 2 or 3 gateways on there, triangulate it, cover the entire site. Any other company on Wilton that have a LoraWAN device but or thinking about doing it, don't have to buy the infrastructure. It's there. You become the landlord of that data, and you can charge them per bit for everything they want to get back. So you get your return on investment back. There's places it's not on this presentation. Engie in France have done exactly that. They've covered all of France in LoraWAN. So they haven't relied on Vodafone or T-Mobile or someone like that. They've done it themselves. Every other LoraWAN user in France has to pay Engie for doing that install. So you could become the provider of that and get a massive revenue stream. Imagine if you've got 6 million devices hanging off your network. That's a lot of money. Even if you're just charging 4 pence or 2 pence per bit of data, every 2 minutes, 2 pence in the cash register. Ka-ching, 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 for 6 million people. So there's always ways to do it. Now, I don't know why Vodafone, T-Mobile in the UK haven't rolled it out. There are a couple of companies in the UK that are starting to roll out a LoraWAN network, but they're being very slow about it. We're actually, believe it or not, Macclesfield Council, 4 years ago, said we want to become a smart council. I said, well, move out of Macclesfield for a start. But anyway, they wanted to be a smart council, and they wanted to have air pollution monitoring, car parking monitoring, and they wanted all the telemetry back. And we said, okay, we can do that. We can put a LoraWAN network in all over Macclesfield. You can buy any LoraWAN device you want, get the data back. And they said, oh, yeah, okay. And they said, right, we've got £5 million to spend. And we said, with the best will in the world, even being a sales guy, I said, I can't take 5 million off you. It's far too much. So we looked at different ways of developing it. And they said, well, we're willing to pay for R&D, hence the other products that we're starting to R&D. And we said, you know what would help us, because the LoraWAN network's not there, can you invest in putting a gateway into orbit? £64,000 to get a gateway into orbit. It's going to be in low Earth orbit, about 25 miles point to point. There's no mountains in the way. So we're looking at putting gateways into orbit so no one will ever have to buy a gateway again. And you're guaranteed line of sight, unless, you know, it ends up like Moonraker and some big thing comes in and eats everything. The gateway is going to be locally powered by the satellite off the solar panels. And you're always going to have that connectivity.
I suspect why they're slow to adopt it is because you've already got other alternatives. You've already got 5G and 6G.
Yeah. But that costs you money. You know, if we want to be a 5G subscriber, it costs us money with every bit of data. That's why it's costing Northern Gas $5 million a year to get their data back. ISDN, PDSN, 3G and 4G cards, they haven't rolled out to 5G because they've refused to, because they're going to use the Aircom and the gateways. ISDN and PDSN lines are going to become obsolete very shortly. That's another reason why they're looking at the LoraWAN network. But for the price of 67 gateways at 1,300 quid each, it's a big cost saving on 5 million quid. Any more for any more?
I just say thank you very much for that.
You're welcome.
Very interesting. A lot of it went straight over the top of my head without anybody else now. I sit back and enjoyed it.
I just look at it as a mobile phone. That's all it is, a mobile phone, getting your data and sending it. Your TikTok videos back to whoever you want to send it to. That's all it is. But thanks for your time, appreciate it.
After that, John, it's the most interesting lecture that I've been to in a number of years.
Thank you. See, I paid him a good load. It was the sandwiches earlier, wasn't it, that kept you happy. Thank you for that. We appreciate it.
Good. Thank you.
If you've got any, obviously you guys are out in Innsbruck. I saw your Foster Wheeler jacket there. I don't know where you're working.
On Seal Sands.
There you go. I expect a phone call. All my details are with Mike. Quite happy to come and do a demo and talk to you about it. But I'm very proud of this product. It's a great one. It's the best in the world at the minute. But I'm more proud of the fact that it's a UK product. Everything is UK manufactured. Even the chipsets are UK manufactured. So it's fantastic for the UK. But yeah, that's it. Thank you very much.
Yeah, no, I'll start because I'm not a member, so I won't be allowed to vote anyway. Thank you very much, John.
I appreciate that, guys. And if, honestly, to get rid of the sales pitch, if you want to start coming along to the committee meetings and join the committee, we appreciate it. We love to have more technical talks. So if you've got anything on the site or anyone that'd love one of these technical talks for us, please get in touch.
All I know about instruments is here, so that's all right. Thanks, chaps.
Cheers now.